was all about stuff like this here. Like what?
4.
X minus 3 radical x plus something, yeah, plus 2 equals 0. Right.
That's easy.
Yeah, this isn't too bad, right? So a lot of these they're going to give you are going to be factorable. They just don't look like what you're used to. Now, if I just said solve this, and you guys pulled the radical x over, got it by itself, squared both sides, that's beautiful. Nothing wrong with that. But what's another way you could solve this because of the form it's in? Yeah, this is really x to the 1/2, right? That's, of course, already x. So is it in the right form to attack it a different way? Yeah, because this guy squared is this guy. So if you wanted to, you could say u equals square root of x. Right, so we always make that u equal to the middle dude, because then u squared must be the first dude. Now, there are ways around this. You don't have to use substitution ever, really. But it just makes it easier to look at. So we're changing the form of it. So what's this now? This will be u squared.
Minus 3u plus 2.
And how do you factor that?
U minus 2, U minus 1.
I like it. So then u is either
2 or 1.
2 or 1. So u equals 2 or u equals 1. And you can't stop there because the question's about x, not about u. So if you give this answer to somebody, what? They want to know what x is. They don't care what the hell u is. That's our own invention, right? So what is u?
So, square root of x.
Square root of x, right? So you bring that back in. So see how you just temporarily replace that with something that looks better. You solve that form, and then you replace back in the ugly stuff from before. So square root of x equals 2, or square root of x equals 1. So x equals 4, or 1. Now what must you do considering this is a radical equation? Every single radical equation, at least the ones with even roots, you have to check the answers to make sure that they both work, right? Now I know neither one is negative, it doesn't make it come out complex, but it still might not work in the equation. So see, let's check 4. 4 minus 3 times square root of 4 plus 2, what's that? 4 minus 6 plus 2, negative 2 plus 2 is 0. Check. So that's good. How are we doing?
I think it's 6.
Oh,
2.
what's square root of 4?
2.
2. Oh, okay.
Times 3, yeah,
okay.
cool.
Okay.
Right. What about 1? So it'd be 1 minus 3 times square root of 1 plus 2. 1 minus 3 plus 2, negative 2 plus 2, 0. Cool. Right. Now, real quick, this might be a good idea. Let's do it the other way. This will be a little review of Chapter 7 stuff. How would I solve this? Looking at it just as a radical equation. What would I do first? What do I want to do when there's a radical in my equation? Get it by itself, right? So I'd actually add this piece over, to tell you honestly. Because then it's basically by itself almost. Now technically, I want you to see where you can start not adhering to the letter of the law here, spirit of the law. You might think I have to divide by 3 and bring all these fractions in. No, you don't. You got your radical basically by itself. There's no other plus or minus. I don't have to FOIL anything over there, right? Leave the 3 where it is. Don't bring in fractions if I don't need to. What do I do to both sides? Square. You just got to be careful over here that this square kills this, but you got to square the 3 also.
No.
If you leave a coefficient on the radical, it better be squared also. And of course here, I don't get x squared plus 4. Right? I get x squared plus 4x. when you FOIL that bad boy out. Right, if you need to, you can write it twice. But you should be at the point where you just think in your head, okay, that'd be 2x and 2x, that's 4x in the middle. You shouldn't really have to write it out twice, but if you do, go ahead. What's the next step here?
Add a negative 9x to the
Yep, so take negative 9x. And this is factorable. What do you get?
8 minus 4, x minus 1.
So you get x is
4.
all right. Then you would check it, but we already did. So cool. So that's perfectly okay. If I don't give you, especially like on the final, if I don't give you any, if I just say solve, damn, you can just solve the damn thing any way you want to, except plug it in your calculator, letting it do the work. Show me something. Okay, cool. So this is the way I really want to see it in this section, though, because that's their point, is treating it like a quadratic. 8.6 was where we got into this here. What can you guys tell me? Let's start off with a specific example. What can you guys tell me about this parabola? I mean, anything you can tell me about this.
It
Anything.
goes down.
Okay, so it opens down because of this.
The vertex is negative 4, 2.
Vertex is negative 4, 2. I like it. Okay, well, okay, yeah, sure. The y-intercept, it's a little bit of work, but it's not too bad. When I plug a 0 in, I get negative 3 times 16 is negative 48 plus 2. Cool. Right?
The axis of symmetry is negative 4.
I like it. Axis of symmetry. X equals negative 4. It's got to run through the vertex, right? Because that vertex is the turning point, but it also is the point that sits on the mirror. It folds on itself, right? It's a reflection of itself. Okay, this would be, well, not too bad. The y-intercept kind of sucks. Do you agree with me? Let me show you a way around that a little bit here. If I wanted to graph this thing, it opens down. I'll give myself some more room there. The vertex is negative 4, 2. Now, I could try to find the X-intercepts if I wanted to, but I'll tell you right now, they would be kind of disgusting. Can somebody tell me how I would do that, though? How would I find the X-intercepts?
Plug 0 in for y.
Yeah,
There is no y.
there is a Y. Where's Y? This whole thing.
That's right there.
So I make it 0 equals this thing. Subtract the 2, divide by negative 3, get some ugly fraction. No, I don't want to do that. I don't have to do that. Screw that. Somebody have another idea? I mean, what do I need to finish graphing this? I just need another point. And the cool thing is I just need one more point, really. Because then I can use, if I have one point, I can use the axis of symmetry. I can just fold it over on the other side. I can just say that it's got to be the reflection over on that side. So how do I get one more point?
Pick a number.
Pick a number, yeah. So f of, let's see, this is a negative 4. Let's say negative, let's go a couple steps away. Let's say negative 2. F of negative 2. Let's see, I get negative 3, negative 2 plus 4 squared plus 2. Are you guys kind of with me here? I mean, never forget, I don't care how much crap we learn on top of stuff. Well, you can find the vertex, you can find the center of the circle, you can find the radius, blah, blah, blah. You can always just plug a frickin' point in to get another point. Always. I mean, that's the way we started with this stuff. Right? So when I get something ugly, here's my y-intercept. Oh crap, I don't want to deal with that. I don't want to go all the way down to 46. Let me just plug in some other point. I don't need the y-intercept, I just need points. Let's see, negative 3. What do I get here? I get negative 12 plus 2. That's still a little low, but it won't too bad for me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At least I can get there better than 46. So at negative 2, it's negative 10. So what other point do I have?
Negative 6.
I like it. So if 2 on this side goes down to 10, then 2 on this side, right? This has got to be the symmetry here. So 2 this way goes there. 2 this way has got to go to the same output. Because it's got to be symmetric. So if on this side I go 2 away from the mirror and I'm down here, its mirror image has got to be over here. And what point would that be?
-6, -10.
-6, -10. Alright, cool. Why am I not surprised it's skinny? Because of the -3, exactly. It's a skinny little dude because it's got a big slope, a big negative slope. That's why it's going down. It's not quite slope, but it's the same idea visually. And then you can always, what's one way to check this without just graphing in the calculator? What's one way to kind of check what we've gotten? What's the one point we got some other way than using the function? This guy. So if I plug a -6 in, I better get a -10 out. And that tells me I'm on the right track, right? Okay, cool. Maybe. Okay. So the general form for a parabola then, at least one of them anyway, there's a few. So this tells you all about up or down. As you say it, Jeff, maybe you want to write the right one, down or up. And it also tells you skinny or fat. Cool, right? Because it's exactly like a slope idea. If it's big, it'll be skinny because it's going to go up or down quickly. If it's small, like 1/2, 1/3, 1/4, it's going to go up and down slower, so it's going to be fat. And the vertex here would be what? HK. Good. H. Okay. That's cool. Okay, maybe. All right, so that's one way to kind of analyze these parabolas. Let me give you something kind of nifty using symmetry again. So we got this here?
I have a quick question.
Yeah.
The vertex HK, like the vertex you used right there was -4 too, but it was a plus 2.
I got you. The equation has a minus in it, and I know this little point, I mean, I hate teaching it like this, but just to show you once, what is plus? Isn't it minus and negative? So x minus h. So what must h be? It must be -4. It can't be 4 because it's not x minus 4, is it?
Okay. So
the way I always remember it real quick is you just make that 0. What makes that 0? -4. That's that.
Okay.
And let me. I'm always worried about saying too much, but this is how I keep it straight. If I have this, the vertex would be what?
2, 5.
2, 5. When it's in there, when it's with the letter, it's the opposite sign. Because to get 0, if that wasn't there to get 0, I would plug a 0 in. The minute I put there, what must I put in to get 0?
The opposite number.
2. So my whole graph has got to shift over 2 to have the same outputs, right? But that's a little worrisome. Then you say, well, why is that the opposite sign and that's not the opposite sign? Because that's not with the letter, is it? So just go with me for a second. Let me see if a few of you guys understand this. If I subtract that 5 over, see how I brought the y back in? Because that's what f of x is. Cool. If I subtract that 5 over, now it is with the y. And that is with the x. So what's the vertex? The opposite sign here, 2. The opposite sign here, 5. So that's another way to kind of see why it does what it does. It does suck that it ends up being opposite signs sometimes and not opposite signs other times. But that's why. Because that number is not with its letter. Because what would this plus 5 do to that graph? It would lift it up. That would be the y-axis, right? So if I put it with its letter, it acts the same way. Opposite sign. Maybe. Okay. Let's see. Oh. Okay. Let me ask you this one. we've had it in this form, right? What's nice about that form? It kind of sucks that I gave you ABC, but could somebody tell me what can you tell just by looking at it? Like for a specific example, if I knew it was 3x squared minus 5x plus 6, what can you tell just by looking at it about the graph?
Cross X twice.
Maybe. Can't really tell just by looking at it. Most importantly, you can tell the y-intercept, right? What's the y-intercept? Okay, so when it's in this form, I can see the y-intercept really easily, right? When it's in this form, the form we just talked about over there, what can I see easily?
Y-intercept.
Vertex.
Okay.
I can't see the y-intercept here now, right? I have to actually plug it in and solve it. Cool? What is nice when it's in this form? Well, I'm not going to figure some letters over here. Maybe you guys can handle this. I don't know. Can you guys handle that? Is that all right? Let me give us a specific one. I'm just trying to say this could be any number and this could be any number, right? That's just what I was trying to do. I didn't want to use A and B because they're already up here. What can you tell me about the graph of this just by looking at this form? Yeah, the x-intercepts. What would the x-intercepts be here?
7, -1.
I like it. Cool, right? So each of the different forms have their own advantages and disadvantages. The thing about this form, though, that's going to lead us to a quick way to find the vertex. Because I don't know about you guys, but it sucks completing the square here just trying to find the vertex. Right? I mean, complete a square sort of sucks, especially if there's a number that I got to take out and I got to remember, oh shit, I got to triple that. Oh crap. There's got to be a shortcut to finding the vertex. And there is. There's a really kick-ass shortcut. All I know about this guy is the x-intercepts, right? So the x-intercepts were 7, 0, and -1. So if I were to try to start graphing that bad boy, there's that. Wow, Jeff. And there's that. Now this isn't really important at this point, but which way does this thing open?
It goes up.
Up, right? Because it's got to be a positive x squared. So wouldn't it be like this? I think I've said something like this before, but can somebody tell me where must the vertex be? Directly in the middle, somewhere on that line in the middle. In fact, that line in the middle of these is also called the line of symmetry, axis of symmetry. Cool? Because any 2 points that are directly across from each other must have the vertex in the middle. We kind of did the opposite thing. I find one point and then I do the symmetry for the other point. Well, if I have these 2 points, then the vertex must be somewhere in the middle. So what x value would the vertex have then? Yeah, because it's going to be right in between -1 and 7, so it's going to be 3. So somewhere on this line here, right? Because it's 1, 2, 3, 4 away, 1, 2, 3, 4 away, right? Another quick way is what's -1 plus 7, 6 divided by 2, 3. Just take the average of them, right? Just get in the middle. Does that sound good? Okay. And what's nice about this is that the x-intercepts are nice. Are the x-intercepts always nice?
No.
We saw an example up here earlier where the x-intercepts were definitely not nice. They were disgusting as hell. That's why I didn't want to find them, right? How are we doing so far? I mean, if I knew the x-intercepts, you could always find the vertex. Now, I know where the vertex is as far as the x goes. Where is it, though? Is it here? Is it there? Where is it? How do I find that? I know that x is 3 is my axis of symmetry. How do I find the point? What do I always do if I know x? Plug it in. If I know x and I want to know what y is, I just plug it in. So what's f of 3? 3 minus 7 times 3 plus 1. -4 times 4. -16, right? Are you guys with me on that? The great thing about the parabola is it's got that symmetry built in. That should simplify a lot of the crap I've got to do. We've already seen that. Find one point, you got another point automatically. No work. So it'd be at -16. There it is. Okay. And then so what?
Hey Jeff,
Yes.
so you just take
your x, multiply, and that, what you get, that's the point where the vertex would be.
What I want you to realize is, how did we find this x piece of the vertex? By using symmetry. I don't care how you find the x piece of a point. How do I always then find the y piece? I plug it in.
Okay.
So when you go to pre-calculus, and those of you who are going to go into calculus, there are quite a few of you, you're going to be doing this a lot. You're going to be finding x's in a lot of different ways, and then it's going to say, well, what is the value at that point? You plug the damn thing back in. I don't care how you find that x, you plug the damn thing back in, right? Cool. So that's all we did there. So let's see if we can all take the next step. If I have an equation like this, and it won't factor, how do I find the x-intercepts?
Quadratic.
I like it. Quadratic, right? That's exactly what the quadratic formula does. What does it do? It finds the solutions for this equals 0. Right? When I set this equal to 0, my answers are called the zeros of the function. Wow. But they're also known as the x-intercepts because they're the ones that are going to hit the ground. Remember that? Like the ground was the 0 point. You guys with me?
Mm-hmm.
So x-intercepts are found by setting this equal to 0. That's exactly what the quadratic formula does. It's built on this equal to 0, isn't it? So what would the x-intercepts be for this?
Minus
Yeah, minus b plus or minus square root of p squared minus 4, I see, all over to it. Blah, blah. Right?
Mm-hmm.
That's quadratic formula. Now, notice something interesting about this quadratic formula. Let me do a little something that we normally don't do. Couldn't I do this if I wanted to? Because I'm just a weird dude? Isn't that the same thing, right?
Yes.
Is that cool?
All right.
So there's going to be an x-intercept. I know I don't know what the hell b and a and c and all that crap are, but there's going to be an x-intercept at negative b over 3 plus this, right? Just to kind of tell you guys, I'm going to come up at the end of this whole discussion, we're going to have a very short, quick way to find a vertex. There's not going to be a lot of work involved. Explaining why it works takes a little bit of work, right? So, and then there's going to be an x-intercept at negative b over 2a minus this, right? That actually could flip-flop depending on the signs of a, b, and c, but let's just go with it. Right? There's this x-intercept here, there's this x-intercept here. How do I find the vertex when I know the two intercepts? Get the thing that's in the middle? Now this looks disgusting as hell, but it's really freaking easy. What's got to be right in the middle? What x value has got to be right in the middle? X is me, I like it, but I want to know exactly what it is. Do you guys notice? How do I get to this? How do I get to this point? Don't I take negative b over 2a and add this? And how do I get to this point? Don't I take negative b over 2a and subtract this? So aren't both these are the same distance away from this? This is negative b over 2a. Negative b over 2a, give or take this to get to the intercept. So don't I start at negative b over 2a? Add something, subtract something. Sweet. I got one convert. I like it.
Get it.
Alright, I desperately want it to make sense. It's exactly like what we did over here. We knew the intercepts, what's in the middle. Well, I added 4 to 3, I subtracted 4 to 3, so 3 must be in the middle, right? Same thing here. What did I add and subtract from? Negative b over 2a. That's got to be in the middle. So here's the kick-ass thing about this then. After all this crap, here's how I can find, if it's in this form, I like this form for one thing because I can see the y-intercept. If I could just see the vertex as easily, and now you can. And now I don't need completing the square to put it into the other form. So watch this. So what's the y-intercept first off?
9. Negative 9.
0, 9.
Oh, yeah. Sorry, 9.
To find the vertex, you do two things. One, the x piece of the vertex. the x piece of the vertex must be the thing in the middle of the two x-intercepts. Is it easy to find the x-intercepts here? Hell no, because that thing don't factor, right? So I use the shortcut, negative b over 2a. Negative b over 2a. That's how I find the x piece of the vertex. Just like we found the x piece by going in between the x-intercepts, the 1 and the 7, or the negative 1 and whatever it was. Bam. Yes, ma'am.
So you would go negative b is
Yeah, what's
negative
b?
4.
B is negative 4.
4.
So it'll be negative 4, right? Because b is negative 4.
Right.
And
Divided
a
by
is
2 times 1.
1. So where is the vertex? At, yeah, you get 4 over 2. At 2, comma what? So I know the x piece is 2. Just like we did earlier, we saw it had to be 3 earlier. Remember that? It had to be a 3 because that was right in between the two x-intercepts. What did we do next? To find the y piece, we plug the damn thing in. So now plug x equal to 2 back in. F of 2 is 2 squared minus 4 times 2 plus 9.
4.
Yep. 4 minus 8 plus 9. 5. So what's the vertex?
4 or 2, 5.
X is 2. Y is 5. So I didn't have to complete this guy's square, right? And remember, why does this really make sense? What's quadratic formula again? Where did it come from?
It's a shortcut.
It's a shortcut for completing a square. So before we had to complete the square for this dumb thing to find the vertex. And then I go, wait a second, quadratic formula is a freaking shortcut. I should be able to use it. And yes, we use this piece of it. Because that's the piece that's right in the middle for the symmetry. That kicks so much ass. Believe me, in pre-calculus, you're going to be using this like crazy. You're going to have these functions like the profit function. You're going to want to know, what's the maximum profit? What price do I set it at to get the maximum profit? Well, you just find x equal negative b over 2a, and then you plug it back in to see what the max profit is. You find the vertex of that thing, right? Well, that'll be later. I'm just telling you what's going to happen later. All right. So you guys try this problem here. And think about it. To graph this, wouldn't it be really easy now? Because I know the vertex is 2, 5. And I know the y-intercept is 0, 9. 1, 2, 3, 4, 5. There you go, John. So I know another point has got to be over here.
4.
And then I'm done. I mean, that's you can't beat that. That's awesome. So all I was missing before was that shortcut, and now we got it. The negative b over 2a. So you guys find vertex, y-intercept, axis of symmetry, and then graph this. Let me make it interesting here. Sure. Oh, I made it a little too interesting, sorry. I want to really, really freak you guys out. Make this 8. Earthquake. Bless you.
Y-intercept should 5 by 2 or no?
Why?
For Y-intercept.
How do you always find y-intercept? Make.
X0.
So what do you get when you make x0? So don't overthink it. Even if you take a 2 out, it would still be twice -3. It would still be -6 at the end, right? So x and y intercepts don't care what the hell's going on. They just say, oh, set the other variable equal to 0 to find me. That's all. They don't care what's going on in the function. They just say, do this, and you'll find me every time. So what's the first step to find the vertex?
I got 2.
So x equals -b over 2a. So -8 over twice 2. -8 divided by 4. Yeah. Be careful now. Second step, you plug it back in, f of -2. So you get twice 4 is 8, minus 16 is -8, minus 6 is -14. Cool. So now you see why. One little giveaway is this opens up and the y-intercept is way at -6. The vertex has got to be even lower than that then because it opens up, right? So I knew to kind of make my graph kind of heavy on the downside there, right? Somebody have a question? Yeah.
Where do you get 14 from?
Yeah.
I got 16.
All right, let me see. So if you plug in a -2, you get twice -2 squared plus 8 times -2 minus 6.
So it's 8 minus 16.
Never mind, I'm good.
Okay. Oh, you looked up a negative there, maybe?
Yeah.
Okay. So yeah, that's how I get negative.
That makes sense.
If you ever get a vertex that's above your y-intercept that's supposed to open up, you're like, whoa, wait a minute, right? You guys see what I'm saying? So I know it opens up. So my vertex got to be below my y-intercept. Otherwise, I know right there I made a mistake.
Right, okay.
And what's the axis? That's going to be easy now. -2. Just got to go right through the vertex, right? So I know the y-intercept is 0, -6. 1, 2, 3, 4, 5, 6. My vertex is at -2, -14. Let's see, 6, 7, 8, 9, 10, 11, 12, 13, 14. I can count. There's my axis of symmetry. And what's one more point that I can use? Yeah, that'll be -4, -6. I like it. So now my parabola is going to just be really skinny here. Go up. Go up. Can somebody tell me, how do you find the x-intercepts? True. How do you find them? I mean, you know, I gotta be careful again. You know, well, there it is. No, but how do you get exactly the number of what it is? What would you do?
Y equals zero.
So besides plugging in the calculator, what do you do? We know. What do you do with this?
Factor
The distance.
Yeah. Factors you can.
or quadratic formula.
And that, just to kind of cut to the chase, I don't think that'll factor. Right? So quadratic formula, exactly. Right? You guys with me? When you have something that won't factor, how do you find the x-intercepts? Quadratic formula, right? For the quadratic.
We can calculate the distance between 2 points. -4 and 0, it will be -2. The distance. For the x's.
For the x-intercepts?
Yeah. No. Yeah. No, for the x's.
Yeah, it's -2, so it's going to be right in between the two x-intercepts, but I don't have that distance.
But
To
you
get-
have in the lower part, you have 0, -6, and you have -4 and -6. So it will be -4 plus 0 or 2.
Won't be that easy. Because I don't know how far this is away from that. I don't know how far that is away from that, right? Once I'm at this level, I don't know how far that is anymore. That's the thing. There's no quick way to get it. In fact, we know ahead of time it's not going to be nice numbers because this thing won't factor. If this thing won't factor, they are not going to be nice. They're going to be irrational. Just find them real quick, because I've got, like, I think it's going to be a little more than 1, and in between -4 and -5, if I've drawn my graph correctly, which probably my scale sucks, but we'll find out. Let's do it. How do you find the x-intercepts? You just do the quadratic. A is 2, B is 8, C is -6. Negative B, give or take, B squared, for AC to A. The little old man, that's all I'll be remember. Negative B. 64 plus 48. Right. Yeah, 8 times 6, 48. 64 plus 48.
112.
Cool. What do you think you could maybe do with 112 there?
No.
Actually, well, let's see. I want exact answers. So somebody help me out. Do that in the calculator, and do this in the calculator. In the calculator. Maybe I'll do it at the same time. Gosh, maybe not. For a math teacher, I suck. I don't bring any calculators.
First one's -13.29.
Say again?
-13.29.
No, I don't think so.
I have -5.354.
No, I don't think so. I think it's going to be between 1/2 and 1/3. That's my guess. 1/2 and 3/4. It's going to be like 0.6 something.
0.645.
Good. That
Yeah.
sounds good. Be careful now. Of course, when you plug in the calculator, you got to tell what stop is. I think that's what's going on, maybe.
Oh, that's right.
Right. So here's the same thing. Be like negative 4 point something.
Negative 4.6.
4.6. Blah blah blah. Okay. So that's pretty close. I went a little crazy with this side. It wasn't really above 1, it's below 1, right? But it's still close. This one was pretty good. In between -4 and -5. Okay, maybe. Did I really need to find the x-intercepts? No, not really. Not just for graphing it. We already got enough, right? Okay. Just in case somebody asks you to find them. That's how you do it. Okay. So if you want to see a little rundown of that, again, it's on page 661. They actually approach it a little bit of a different way, but they summarize. They go one step further, and I don't like it. They actually come up with an equation for the y piece of the vertex. I think that's silly. Just plug the number back in. I don't need the equation is 4ac minus b squared divided by 4. Who cares? Just plug the x piece I find back in. Why mess with all the b and a and c crap? Just plug it back in. Okay. Blah, blah, blah. Here. So on page 664, if you like summaries of stuff, there is a good summary of everything we've talked about. Most everything we've talked about with parabolas. Okay. So the homework is going to be really straightforward. Just going to ask you exactly like we just did. Find the vertex, find the y-intercept, graph it, you know, bam. Pretty straightforward. We skip 8.8. That's not in the curriculum, so you'll appreciate that because that was more word problems. 8.9, I was debating over 8.9. Has everybody got this one? But 8.9 is kind of important, so let's do 8.9, then we'll take a break, I think. I already did a problem like 8.9 in a bonus on an earlier test. It was something like this here. I can't remember now. It was like that. And we talked about it very quickly, and I said that in a future section we'll actually learn how to do this all the way out. And here it is. And by the way, I can't believe that next week is it. It's crazy. Just look at my calendar like, holy shit, there's one. I can't solve this directly. Because if even if you factor this thing, I can't just say x greater than 0 or x plus 5 greater than 0. I can't do that because greater than 0 talks about the signs of it. That says I want this expression to be positive. Right? So it's true if x is greater than 0 and x plus 5 is greater than 0, then it's positive. But what if x is less than 0 and x plus 5 is less than 0? Then it's also positive, right? And if you get into it, if you have more expressions here, you have like 18 cases to cover if you want to do it that way. So I think maybe you're in my boat now that I don't want to do it that way, right? There's a much better way to do this. When I've got a graph of a parabola, when will it change sign? So if I have a graph that's opening down, opening up, it's positive here, right? Mm-hmm. It's not going to change sign until it hits its. Yeah, until it gets, and then it's going to change sign again, right? Mm-hmm. Now you might have a parabola, of course, that never changes sign, and you might have a parabola that only changes, that actually never changes sign, but it looks like it might, and then it turns around, it decides not to, right? You guys with? But that'll come out in the work, thank God. They're not cases you got to take care of. The work will do it for you. So here's the cool thing about this. The most important points then defined are those, what I call doors. When I teach pre-calculus, you do a lot of this stuff where you go, where does it go through the x-axis? And will it just touch or will it go through and all this crap? So I say, those are my doors. That's how I can get through the x-axis, right? The most important thing to find here then are the doors. Because then on either side of that, I might be positive or negative, right? So one thing to realize is I'm taking this algebraic equation and I'm making it into a question of sign. That's all I need to figure out is what is the sign of this equation? Where is it positive? So if I can find an easy way to see the places where it's positive, here's my answer. So where is it 0 is where we start because we know that's where it could change sign. So where is it 0? It's 0 at, okay, 0 at negative 5. A little z there for 0. And it's 0 at 0 in this case, just because that's got an x there, right? That'll make it 0. I really desperately want you to get this because a decent number of you raise your hand when I ask who's got to go all the way to calculus. Trust me, you're going to do a ton of these in calculus, a crazy massive amount of these in calculus. Investigating where things are positive or negative, right? Once I figure out the zeros, I've made these 3 regions. Do you guys see that? Can it possibly change sign anywhere in here? Because what do we say? To do that, it'd have to like magically transport itself over. The only time it could change sign is on either sides of a 0. So if you plug in like a, let's say a negative 1, what do you get when you plug in negative 1 here? You get negative 1 times 4. You get a negative number, right? So it's got to be negative everywhere in there. You guys with me on that? Because the only place it can change sign is when it goes through the x-axis. Those are the only places it can change sign then. It's sort of like a test point. I only got to look at one test point, and then it's either shade that way or shade the other way. It's sort of the same idea. When you plug in a 1, what do you get? 1 times 6 is positive.
But
So it's going to be positive everywhere forever. And when you plug in a negative 6, negative times negative is positive. I don't even care about the number. Sometimes I'll tell you plug in negative 18 billion. I don't care about that. And this negative times negative is positive. So what's the answer to this question? What is the answer? I was trying to say equation and question. What's this question asking me? Where is this more than 0? Where's it positive? So where is it positive? From negative infinity all the way up to negative 5.
negative 5.
Do I include the negative 5?
No.
Can it be allowed to equal 0? No. So I don't want to let it equal 0. Or
0 to infinity.
0
0
to infinity. So let me see if I can make an interesting problem. You do it, Jeff. Maybe you can't. Screw it, Jeff. Come on. Okay. Oh, Jeff.
That's okay, just keep leaving it where it was.
Thank you so much. There you go. Okay. Equals. Let's say less than or equal to 0. Let's see if I made something that works. No, I probably didn't. Yes, I did. Okay, we'll see. What do you think I have to do first? Same thing I did over there, right? Same thing I had to do first there. To find the zeros of this, if I factor it, I can see them just stepping right out of the page, right? So how do I factor this thing?
Group it.
Yeah, so group it. So what comes out of that? 4x squared? Not 4x squared, what's that? Just an x squared comes out. 4x minus 1, right? Because this has no 4. Minus 9. 4x minus 1, right? How are we doing? Okay, okay. Then what's the next step?
4x minus 1.
X equal minus 9.
Alright, right? Just grouping, take the 4x minus 1 out, left with the x squared minus 9. What can I do with this? You're not done yet, right?
X minus 3.
Now purposely, that's why it was taking me a little while to figure it out, because I wanted to end up with the fractional answer just to show you they're not a big deal. Because I just want to pick a number that's on either side of it, and I can just pick a whole number if I can, right? So where are my zeros?
1 over 4. 3, negative 3, and 1/4.
Yeah, add the 1 divided by 4, so 1/4. Right, remember, just set this equal to 0 and solve. Add 1 divided by 4. So now I can make my little number line. I got a negative 3 and 3 and 1/4. So 1/4 about right there. 0 there, 0 there, 0 there. So do you see, I actually already have 3 answers, because it says less than or equal to. So I know those are going to be parts of my answers, because that's where it's 0. What do I do now, though? to start answering the other part of the question, less than 0. Right? I want to find out where it's negative. Yeah, put some test points in. So if I put in a negative 4, let me see if you guys are cool with this. If I put a negative 4 in here, isn't this going to be negative? I don't care what the hell number it is. I just know it's going to be negative minus 1 is negative. Negative minus is negative. And negative 4 plus 3 is negative. Negative times negative times negative is negative. Cool. How we doing? If you get the number, I don't care. You don't. That number doesn't matter. It's the sign that matters, right? What's a good number to put in from here? 0.
Okay.
0 is the best number in the world because I can actually go to the beginning. What do I get when I put a 0 in?
9.
Positive number. Over here, 1 would be good, right? I get, if I plug a 1 in, I get positive, right? 4 minus 1 is positive. 1 minus 3 is negative. 1 plus 3 is positive, so I get negative. Some of you guys might be able to guess what this is going to be.
Positive.
See, negative, positive, negative, positive. So when it's not always going to be like that, you got to be careful. So when I throw in like a 4, I get positive, positive, positive. So sure enough, that's positive. Does everybody see where I'm getting these signs from? So again, here we plugged in a negative 4. So when I plug in a negative 4, I'm trying to do this without doing too much work. This is negative 17, this is negative 7, this is negative 1. Again, I don't care about the numbers. Negative times negative times negative is a negative number. So it's negative all throughout here. Why is it negative everywhere in here? Because it can only change sign when it goes through the x-axis. And it only goes through the x-axis here, here, and there. Do the same thing throughout. Put a 0 in, negative, negative, positive, positive. Put a 1 in or a 2 in. Put a 4 in or an 18 billion in. Right? Plug in any number you want to in that region. So what's the answer going to be? Where is it less than or equal to 0?
Minus.
Here, right?
Yeah.
So from negative infinity up to, do you want to include it?
Yes.
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 Less than or equal to. Or, where else is it negative? 1/4 up to 3. And that's it. Right? Now this next step you don't have to ever do. This is it. This is the answer. But I want you guys to realize something. See how this says it's negative? Now I can kind of graph a little rough graph. It's negative, then it becomes positive here, then it becomes negative again, then it becomes positive again. So it's going to look something like that. I got a little Loch Ness Monster on, sure. Do you guys see that? You're not going to have to do that. If you go into pre-calc calculus, you're going to have to actually, want to give some rough sketches so you know what's going on. For me, this is it. This is the answer. You found where this equation is negative or 0. There. Let's do one more and I'll give you a break here. I want to show you where the sign doesn't change and try to show you a nice shortcut for this stuff. Because if it always did this, if it always changed sign every time, negative, positive, would you ever have to actually check every damn region? No, if you check this region as positive, you go negative, positive, you're done. It doesn't always do that, though. But it's a really cool rule about when it does it and when it doesn't. It makes it very quick to do these problems. So let me cut to the chase here. Some of you guys might notice the new element here. Not really. I mean, here we had a factor, so I just went ahead and factored it for us, right? So it's already factored, so I can already see my what? What can I see?
Zero.
My zeros. What are my zeros? Okay, so 1,
-3
-3,
and 5.
okay, cool. Here, mate. Get out of here. Alright. So, I'll do this all the way out and then I'll see if you can see the shortcut. Alright. So to investigate this, I can throw in there -4,
Negative.
right? So if I throw in there -4,
What is
I'll get, this is squared, right? So it doesn't matter what's going to happen. It's positive. -4 here would make it
negative?
negative. -4 here would make it
Negative.
negative. So overall, that would be what?
Positive.
Positive times negative is positive. What about if I throw in there x equal to -1? This will be
0.
-1 minus 1 is
Positive.
Positive.
-2 squared is, yeah, it's going to be positive. Always going to be positive because that's squared. -1 plus 3, positive. -1 minus 5, negative, right? So in there it's going to be negative. How are we doing so far? So far it's changing signs again. Jeff, what the hell are you making a big deal out of this stuff for? Well, now if you plug in like a 2, what do you get? 2 minus 1 doesn't matter, it's going to be positive. 2 plus 3 is, 2 minus 5 is, and so overall it's, if you throw in a 6, so this is not bad. This is a way you can kind of do the work, right? If you want to kind of keep it, you can probably organize it better. If you do x equals 6, what do you get? You'll get positive, 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 yeah, positive. Cool. Do you notice specifically the 0 that it did not change sign around? Which 0 did it not change sign around? 1. What was special about that 1? It came from a squared piece, right? Because what would x minus 1 squared do? Some guys might realize it would go like this. Would it change sign? No, it doesn't go through, right? Whereas these other pieces are like lines. They're going to go through, aren't they? So if it's to an odd power, it will change signs, right? Like the -3 is to a first power, it's odd. That's to a first power, that's odd. It changed signs here, didn't it? See that? But if it's around something that comes from an even power factor, it won't change signs around there. Right? That kicks so much ass, because now, I did tell you I was going to show you just one more, but that's too bad I lied. If I have this, so now 0 at